Antique, located on the west coast of Panay Island, is recognized for its scenic beauty including pristine beaches, islands, diving locations, waterfalls, and mountains. By its unique geography, it has been known as the province where the mountains meet the sea. Going to the northern part of the province, the town of Libertad promotes mat or banig weaving as its main cultural activity. Banig weaving is a traditional craft in which the strips are interlaced in over and under pattern. The leaves of pandan plants, known as bariu, are used as the raw material for weaving. Through a series of tedious processes, from slushing of bariu leaves, sun-drying under direct of sunlight, gradual beating of the dried leaves, shredding of these leaves into strips, up to the weaving course, serves as the living tradition of Libertadons. This makes bariu-based products as the one town, one product of the community since 2007. With the creativity and intricate styles on banig, embroidered mats are extremely attractive. Embroider a mat or ang pagborda kang banig is by means of inserting colored strips or buri to form exquisite designs. Rosal flower, found in their place, was the source of inspiration in making designs. The embroiderer or ang manugborda are motivated to craft this design because it symbolizes purity, love, and refinement. With various functional and decorative purposes across cultures, we are interested to find out the mats on an embroidered mat having a Rosal-inspired flower design.
The context of this investigation lies in the embroidery of mats and the mathematical concepts embedded by the embroiderers in their embroidery activity. We embarked on a journey to Ati Cave where we actively participated in participant observation and direct interaction with the weavers and embroiderers. This immersive approach helped us to search deeply into the details of mat embroidery, facilitating the vital insights and experiences associated with this craft. We trekked through the bariu plantations where mat weaving and embroidery start. We watched closely as skilled hands crafted bariu strips, weaving them together with care to create the basis for stunning artworks. Essential data were collected from 2 skilled Antiqueño mat embroiderers. Each has a minimum of 20 years experience in this craft. Subsequently, we meticulously delved into the mathematical intricacies underpinning the completed embroidered mats. Finally, we undertook mathematical analysis to thoroughly examine and interpret the gathered data.
Good afternoon, everyone. The first competency in the integration of banig embroidery is in the learning competency of grade 8 K-12 curriculum, wherein the learner illustrates the rectangular coordinate system and its uses. Plotting of points is the fundamental skill in banig weaving. Weavers first identify the center or the origin of the mat as what lie in the Cartesian coordinate plane. It allows the weavers to plan the design before starting to weave. This reduces the risk of error and wasted material during the weaving process. Weaving pattern can be represented as point in the coordinate plane.
On the other hand, as observed and performed on how mat embroidering was done, some mathematical ideas were discerned, including patterns that illustrate the concept of arithmetic sequence, which is a competency in grade 10 mathematics. While learning the whole process, there were patterns in the over the part of the white strip that is visible to the observer and under the part of the white strip that is hidden, procedure of embroidering. Through counting, the total number of overs in every row could exhibit a trend of an arithmetic sequence. Let us take a look at this illustration. For one over identified in a row, there are 2 unders. This gives a total of 3 square units in all. With another white strip, for 2 overs identified in a row, there are 3 unders. This gives a total of 5 square units in all. These observations lead to discovering a pattern. For one more than twice the x number of identified overs in a row, there is f of x total number of square units, which can be expressed into mathematical function f of x equals 2x plus 1. To check if x is equal to 1, then f of 1 equals 2 times 1 plus 1, which is equal to 3. Next, if x is equal to 2, then f of 2 equals 2 times 2 plus 1, which is equal to 5. The resulting answers conform with the observations made. For validation of the mathematical function, if x is equal to 3, then f of 3 equals 2 times 3 plus 1, which is equal to 7. The table summarizes it all that as the value of x increases by 1, the value of f of x increases by 2. This implies that the values of f of x have a common difference of 2. Thus, the order of the numbers illustrates arithmetic sequence.
Another integration of the Banig embroidery is in the learning competency in the grade 5 mathematics in the K-12 curriculum, in which the learner visualizes, names, and describes polygons with 5 or more sides. We define polygon as a closed plane figure bounded by at least 3 sides, which are called line segments. In the embroidered banig, we can see closed plane figures, a 16-sided polygon called hexadecagon and a 12-sided polygon called a dodecagon. We can also say that the 2 polygons are irregular. Hence, as a contextualized example, we can allow our learners to identify the number of sides, describe the given polygons, and name them. These will engage the learners with the real-life examples and enable them to appreciate polygons around us.
One of the mathematical concepts that are observed in the banig making and embroidery is the concept of finding the area of irregular figures. In the identified polygons earlier, we can say that the 2 polygons are also irregular figures as they are made up of unit squares. Thus, the concept falls on the competency found in the 4th quarter of grade 4 mathematics. As we make a digital copy of the flower, we see that the whole figure is made up only of unit squares, composing 8 petals having the same number of unit squares and the pistil with 12 unit squares. Examining the petal, notice that there are 26 unit squares. Recall that a unit square is a square whose sides measure 1 unit, and we can find the area of any irregular figure made up of unit squares by simply counting the number of squares in the figure. So we can say that the area of each petal is 26 square units and the area of the pistil is 12 square units. Considering that there are 8 petals and each petal has the area of 26 square units and the pistil has 12 square units, we come up with an equation of P times S plus M, which leads us to the area of the flower that is 220 square units.
Another competency where math embroidery could be integrated is in the topic functions under graphs, which is to represent real-life situation using functions, including piecewise function. This competency could be utilized in grade 11 general mathematics classes during the 1st quarter of the year when students are learning and wanting to understand the concepts of mathematics in a real-life scenario. In math embroidery, we wanted to understand the value of monetary aspect of the craft, giving real data about how much a piece of embroidered mat is worth by constructing a mathematical model to solve real-life problems. Collecting data can be done through field interview and modeling the equation of the cost of embroidered mat. According to the local artisans, the cost of weaving mat varies according to the size of the woven mat and ranges from 250 to 700 pesos. For a single mat, it is worth 250, double 400, and family size is worth 700 pesos. While the price for embroidery also varies according to size, ranges from 300 to 700 pesos, where for the single mat, it costs 300, double 500, and family size 700 pesos. Considering the given data, I was able to formulate the cost function where x is the number of embroidered mat. So C of X is equal to the weaving cost plus the embroidery cost. On this case, I was able to formulate three equations. First, C of X is equal to 250X plus 300X when the size of mat is single. 400X plus 500X when the size of mat is double. And 700X plus 700X when the size of mat is family. Our function is an example of piecewise function because the domain is partitioned into several intervals on which the function is defined. To illustrate an example, consider the problem, how much is the cost of a single embroidered mat? In this case, we will use the first equation, C of X is equal to 250X plus 300X. Evaluating C of 1, the cost of a single embroidered mat is 550 pesos.
Banig embroidery, a traditional Filipino art form, offers a fascinating blend of culture and mathematics in the modern world. As stated in said Memo Order No. 20, Series of 2013, in the topic, The Nature of Mathematics in the Modern World, with intended learning outcomes, identify patterns in nature and regularities in the world. With this embroidery in banig and with the use of GeoGebra, as seen in the figure, we find the existence of symmetry within the patterns in the petals. When we talk of symmetry, it refers to the harmony and balance between the components that make up whole. Symmetry in the context of transformation geometry can be seen in various forms such as translation, reflection, and tessellation. Translation is a geometric transformation that moves every point of figure, shape, or space with the same distance in a given direction. Tessellation is the tiling over a plane with one or more figures, such that the figure will tilt the plane with no gaps and no overlaps. Reflection, on the other hand, is a mirror image of the shape. An image will reflect through a line known as the line of symmetry.
I know that you've learned a lot from this presentation. I will going to share to you what our concluding statements which summarize the key points discussed in this presentation. First is, the concept of embroidery in mat is that it allows for the visualization of abstract mathematical ideas. By creating embroidered design that embody this concept, individuals can see and interact with mathematical ideas in concrete and visual manner. This can enhance their understanding and intuition, especially for learners who are more visually oriented. Second, embroidery can be a powerful tool for communicating mathematical ideas to a broader audience. By creating an embroidered pieces that represent mathematical concepts, individuals can spark interest and curiosity in mathematics among those who may not have been previously engaged. Third, embroidery in mat projects that involve mathematical patterns or puzzles can develop problem-solving and critical thinking skills. The process of planning and executing an embroidery design requires logical reasoning, spatial awareness, and attention to detail. Mathematical embroidery can challenge individuals to think analytically and creatively as they navigate the complexities of this project. As you have seen, the flower that was embroidered in mat was subjected and projected in GeoGebra. It generates new ideas and connects in the concept of both algebra and geometry concepts. In other words, it promotes creativity and artistic expression, facilitate communication and outreach, and foster problem-solving and critical thinking skills. By incorporating embroidery into the study of mathematics, we can make the subject more engaging, accessible, and enjoyable for learners for all backgrounds. And that concludes our presentation. Thank you, and we hope you've learned something mathematically from our presentation, which is all about maths in embroidered mat.
Through high, it's more fun in the TK.